Hi everyone, this is Promotory. Today's video covers the ZIL gearbox. I'm currently working on a PAZ bus gearbox, which is a high-speed model. I don't remember the exact model of this gearbox right now. I'll write it in the description or add the model in the subtitles. I've already worked on it multiple times. What's the problem with it now? Why was it removed? All the gears drop out, except for first and fifth. Second, third, and fourth. So the first gear is unsynchronized. I see it doesn't really drop out. This one is second, this one is third. Fourth is direct. But fifth gear doesn't drop out. Because during the last repair I installed this new gear and the condition of these splines is good. During the last repair I also replaced the synchronizers and all the bearings. Now we took it apart because the gears are dropping out. I looked at these teeth that engage with the synchronizers and they're all worn out. What other problem do we have? I've already worked on this gearbox several times and all the bearing seats here are already worn out. That means the bearings are loose here. You can even see that it's already starting to crumble. Also, on the intermediate shaft we can see the constant mesh gear and it's developed a crack. What's the gearbox's scope of work? So, we need to replace all the bearings, replace this constant mesh gear, the intermediate shaft, replace the synchronizers, and replace the secondary shaft gears, second and third, as well as the primary shaft. Also, all the small items like washers and gaskets. We also need to replace the housing because all the bearing seats and bearings are damaged. And here we can see, I worked on it before, I already put a washer and a ring in here. You can see the wear right here. The bearing is already loose in the housing, causing the cup to wear out too. I once put a washer in here, but it doesn't really help. So it also needs the cup replaced, maybe some covers and so on. It was estimated that the repair would cost about 45,000. And now the question is whether a completely new gearbox will be purchased. There are some for 45,000 and some for 60,000. So we'll have to see. Or the second option is to use a ZIL gearbox. That is, there's a gearbox from Soviet times. I checked the casting here. It's from 1983. From the Soviet era, the 1980s of the last century. Sounds good. We can see that it was lying somewhere. You can see there's moss growing on it already. So, here's the bait glass atom load testing. The box. The components are right here and it comes with a constant mesh gear and this gear is right here. It goes. Fourth gear of the intermediate shaft. So I need to swap these two. Moving on. This gear is in good condition because last time I installed a new one. So for fifth gear we'll use this gear. Well, we'll have to replace the input shaft. This one is in bad condition and the other input shaft is different, so we'll have to get a new input shaft. So have you already drained the oil? There was no oil here and it wasn't a grove. I'm checking everything by taking it apart. Let's go. Alright, so I opened the cover and we can see that it's not e-grove in here, it's also from back in the day Soviet oil. So basically, I can't even turn it. It's that viscous, that thick. They don't even make e-grove like this anymore. So we can see that visually all the gears are intact. I can't say anything about the synchronizers yet. We'll take it apart now. The main thing is that visually all the gears are intact. Now we're taking it apart completely, cleaning it and checking it out. Alright, now I need to unscrew these two nuts. I need to engage two gears to stop the shafts from spinning, then unscrew them. So, as you can see, I've engaged first gear and second gear is also engaged. That means two gears are engaged and accordingly the gearbox doesn't spin. We normally have 46 mm nuts here, but now there's a 50 mm nut and the flange won't come off, so it's either rusted or just typical Soviet quality. Everything fits too tightly, so we'll remove the flange with a puller. First, we need to unscrew this nut. I got the flange off somehow. Everything is rusty and stuck. So we can see that the seal was sitting right here. Under the seal it looks more or less okay. But this inner part which sits in the gearbox, you can see it's all rusty. That's a layer of rust that's built up over many years. Basically it's just like a condenser here. The inside is totally rusted. No grease was used, so everything rusted. We're not interested in that. We're focused on the internal parts. Alright. Next, I remove the covers and take out the bearings. I take out the shafts. As we can see, instead of a speedometer drive, there's just a washer acting as a spacer for the flange to rest against. Interesting. So as the speedometer drive, what's happening? And right away we can see that the bearing has a crack, meaning the inner race of the bearing is broken. Here we can see the crack. Well, the bearing is a minor issue, but we're interested in the shafts, gears and bearings. I was going to replace it anyway. So we can see that our bearing has some play. The bearing is in bad condition and needs replacing, but it's tightly fitted in the housing. See, it doesn't even move. So that's actually very good. We're really happy about that. So we've removed the primary shaft. We can see that the bearing has fallen apart, but we don't really need it anyway. I'll repeat, we're not interested in the bearings. We're interested in the shafts and gears. And actually we're not even interested in this primary shaft, since it needs to be replaced anyway. The bearing took a lot of effort to remove from the housing, which is exactly what we want. It came off the shaft easily, likely because it's cracked. See the crack here. The inner race of the bearing is broken, which is why it came off so easily. So what else can we see right away? We can see that the primary and secondary shaft bearings here are roller bearings. They've crumbled and fallen apart. And we can see that the secondary shaft is scored. So the shaft is basically scrapped. That's not an issue. We can use the shaft from the other gearbox since it's in good condition. All right. Now I just need to clean everything up and check the condition. The first gear pinion. We'll also clean it up. Check it now. Now we need to take out the intermediate shaft. So, next my task is to clean all this, disassemble the secondary shaft and check everything completely, the condition of the teeth. And then we'll decide what to do next. What we'll take from this gearbox. Or if we'll end up buying a new gearbox. So I washed the shafts, took them out of the washer, and let's see what we've got. Things aren't as good as we'd like. So first, the main shaft, the secondary shaft, we have to throw them out because this bearing here broke apart. This bearing, and you can see the scoring here, even just by touch, you can feel that there's a dip here. So we need to discard the shaft. We also don't need this gear. It's from a ZIL. We're only interested in these two gears. You can see that the oil level was here. So the part of the gear that was in the oil is still in relatively good condition. But the part that was on top, you can see the corrosion on it. And this corrosion isn't just on the surface, it has penetrated deep inside. There are already pits here. So we don't need this gear either. We can't use it. The only one we can use is this gear. We can use it for second gear. But again, we need to take it apart and check the condition of the teeth that engage with the synchronizer. So basically there's almost nothing usable here except for this gear. So we can't take anything from this shaft. Nothing here works for us. Now let's look at the intermediate shaft and see what condition it's in. We can see that the splines involved in the reverse gear are all worn out like this, all chipped. Well, accordingly, we no longer consider this shaft. That means we won't take anything from this shaft. Nothing here suits us. And accordingly from this shaft, we could have taken these gears. But I just counted the number of teeth on the input shaft and the number of teeth on fourth gear, and they turned out to be different. So accordingly, nothing here suits us either. So it turns out I took it apart for nothing. Now I'm putting it all back together. What do we have? So I took apart this Soviet-era gearbox, washed the shafts, but these don't fit us. It turns out things aren't as rosy here as I thought. It's impossible to swap these gears around. There are some nuances, like the shaft diameter and the mounting seat, that have different diameters. So basically, I can do it the way I wanted. I just need to. Then, these two gears should be installed specifically according to Zaska. This is our Silovsky shaft. It comes with keys. And accordingly, this is what we have. Fourth gear, the fifth overdrive gear is expected. This is possible but you'll need to install these original gears as Zaska recommends when you get something in between the ZIL and PAZ gearboxes, meaning the gear ratios of all the gears will change. How do you calculate that? That's why I didn't get into all of this, because nothing here really suits us. So how much more? I'll mention one detail. Since the ZIL gear sits on a key, its shaft diameter is 0.05 mm smaller, meaning the PAZ shaft is 0.05 mm thicker there. Accordingly, it fits on hot. There's an interference fit and it clamps down because there's no key. Theoretically, you can use this shaft, but I don't know how it will work in practice, so I won't say anything because I don't know. So these shafts don't suit us since this shaft is defective. And this shaft is also already worn out and defective from this donor gearbox. We're only taking the housing. Since the bearing seats on this housing are damaged, this housing is going to be discarded. We're taking the housing and the cup, the front cover of the input shaft from the donor gearbox, from a Soviet-era gearbox. You can see it's from 1983. So now we're going to clean it, replace the oil seal, and everything else will stay original from this gearbox except for these parts. So what will be replaced? All the bearings in the second gear. The third gear is on the input shaft since we have a high-speed gearbox. The input shaft provides direct drive. The splines here are also worn out. The input shaft and synchronizers will both be replaced. This gear will also be replaced because it has a crack in it. I showed this crack earlier. So all these parts will be new. Here they are already. Here we have a set of gaskets, bearings and all the gears. One gear with synchronization isn't here yet, but it should be delivered today and I'll be assembling it onto this housing. There are two things. First, we need to move the intermediate gear. This one for reverse. So I need to take it off this gearbox and put it here. So the first thing, we can see that here the shaft, the bolt, the plate, the housing and the shaft are all welded together. Everything is welded. I don't know why, but now I'm going to use an angle grinder to remove all of this. I'll unscrew the bolt and knock out the shaft. So that's what I'll be doing now. So, what's the second point? This is the place where we attach. This is where the bracket attaches for mounting the clutch slave cylinder. The bracket is really sturdy like this. So it sits on this surface and is fastened with 3 bolts. So we can see that here we have a flat wall, but on this gearbox we have a window, an extra window, and it's covered with a plug. So if we connect it like this, then we can see as this part rests against this cover, it will pull us out. Right costume off now. Freelance of the third, step into with fruit. This bolt here, so that this bracket sits in place without any misalignment right here. So there are 2 such nuances, this cover and the welded reverse shaft of the reverse idler gear. And now I'm going to work on this gearbox. I just need to take out this gear and remove this cover. That's it. The housing will be thrown away. And for this gearbox, I need to clean these gasket seats, clean off some rust. Maybe I'll paint it. I don't know yet. It depends on how much time I have. All right, let's go. Like this, I cleaned the block, wiped it down with a rag and some solvent, and now my task is to chase the threads. I checked the threads on the caps here and they look fine, except for one. Where the threads are bad is right here, on the rear, on this cap. The threads are a bit damaged here and right here, where the bracket for the slave cylinder is attached. Now I'll take a tap and clean up the threads. I prepared the whole block, cleaned it, blew it out, chased the threads, also cleaned all the covers, the top cover and the rear covers, the cap. Basically, I cleaned and prepared everything. This is already new, it's lying there, the gears are lying there warming up on the hot plate. Now I'll start by assembling the intermediate shaft, putting 2 gears on it while it's hot. Then I'll assemble the secondary shaft, and after that I'll install everything into the gearbox. Namely, to have some tea. So I moved over to the press. The gears are on the tile and have heated to over 100 degrees. Now I'm carrying and pressing them in. Alright, so the gears are in place. Everything went in smoothly. I put the ring on. Now I'm putting on the bearing. But since the shaft is hot, I need to wait for it to cool down and accordingly heat up the bearing as well. For now, I'll put the bearing on the hot plate to raise and I'll drive it into the block. Alright, the shaft has cooled down, the shaft is cold. I've heated the bearings and I'm installing the bearing while it's hot. So, first I install the reverse idler gear. The block is old, the shaft is old. I'm only installing new bearings. Also, so the shaft fits better, so that oil doesn't leak in this spot, I'll apply special glue. I installed the shaft, put in the bearing and it a bit so the shaft presses against the bearing here. Later, when I still have to, I'll tighten this nut on the secondary shaft again. It needs one more turn so that it shifts for me, so I can fix it here. That's how it is. There, the intermediate shaft is already in place. Everything turns well. Sometimes this gear touches, it rubs against the casting on the housing. Here, everything seems fine to me. Next, I need to assemble the secondary shaft. So, just like that, the secondary shaft is assembled. Unlike ZF gearboxes, this synchronizer is a complete non-disassemblable unit. The cones are integrated into the gears as rings, making the system simpler. So that's it. The shaft, the secondary shaft is assembled. Now I need to install it into the gearbox. Next, I need to install a new bearing onto this primary shaft. I only need the ring from this shaft. So I installed the bearing using a heat fit, but anyone who has worked with these rings, Russian, domestic, Soviet ones, knows what kind of... It's painful, but you saw how I removed it. It fits a little bit better. So we take a new bearing. We see that it's in a plastic cage. Nowadays, they all come with plastic separators, so I don't really like that, but there are no others, so we'll have to use this one. The bearing has cooled, and as I hammer it in, you can see how snugly it fits into the housing. The new bearing has no play, so we can see how well the input shaft sits. Next, I need to install the rear bearing. It's on the tile, and I'm hammering it in while it's hot. We can see how everything fit well, how everything went in tightly, there's no play anywhere, everything is just perfect, excellent. Everything is installed, I mean all the bearings, everything has been installed. Now my task is to close the covers. The front, rear and side ones. Pour in the oil and put on the top cover. I heated it up, also installed the speedometer drive. The cover is washed and cleaned. I replaced the oil seal, put a new one. Now I take the gasket, take the sealant and install the cover. I installed the flange from the inside, applied sealant there. I don't know, sometimes oil leaks do them. So I always apply sealant. So after that I tighten the nut. Now I need to torque it down. I engage 2 gears, first and second, so the gearbox doesn't turn. Now I'll loosen and tighten both nuts. I have all the lower ones, so don't forget to tighten them. I broke them loose, put the pipe on, and now I'm tightening them. It's uncomfortable like this. Let's do a different now. That's it. I tightened it like this. I think that's enough for now. I'll make a mark here so the nuts don't come loose, although they usually don't come loose anyway. But still, I'll make a mark. As you can see, I turned it about 1 centimeter more here. That way I dented it a little there. The nuts are tightened. Now I can put this cover on and all the other covers too. So I'm putting on the intermediate shaft bearing cover. I also applied sealant and put on the gasket, and I'm installing it. Right away I'll close the side covers. So I put the cover on like this. I didn't forget to put the washer here. It's intentionally without a washer because, as I already showed, right here I should have a bracket. So it turns out it rests like this. It rests against this bolt, so I need to the lowest possible bolt, and still we see that it's sticking out by about 5 millimeters. Currently I have 2 options: cut off the head at an angle with a grinder, or from this side. Mark it here, and cut out a square here with the grinder so the bolt can drop in. I don't know, I'll see which option works. Well, basically, it's all doable. It's nothing serious. There's nothing to worry. Alright, we'll get to that later. Next, I need to install the second cover. I've already applied sealant to it. Next, I install the cup. After washing and cleaning it, replace the oil seal, put on the gasket, and applied sealant to both sides. The cup is in place. Now I need to install the plug right here. Like this, a metal disc. Let's see, it doesn't fit like this. That means it doesn't go in there, so I need to bend it the other way. And then when I hammer it in, it'll expand a bit. So we take the old race from this bearing and put it here. The cap. And we hit the center so it becomes a bit like a cup. All the covers are installed, everything is closed. Now I need to fill it up. The oil and close the top cover. So, this is first gear, this is second, this is third, this is fourth, and this is fifth. That is on the ZIL gearbox. The gears go in order 1, 2, 3, 4, 5. So I'm pouring in the oil, pouring in the oil. Tatachi 1890 Zelka. So for synchronized, we haven't used this type of oil in PAZ gearboxes yet. We typically use a different one. Requests there from the Hoshka. Well, we'll try and see how the PAZ gearbox works with this oil. So this is our drain plug and this is our inspection plug. So I've roughly leveled the gearbox now and I'm filling it up until I have, well, until it reaches about this plug. It holds about 5.5 liters here. Here you can see the plug, so the oil is filled up to about the plug. Now I'm closing the top cover. I applied sealant, put on the gasket, applied sealant here as well, installed all the gears here, set it to neutral, TV vitro, set all the forks as well, neutral. The cover, and now I'm trying to shift gears. I need to make sure that all the gears are engaging. So as we can see, everything is fine, all the gears are engaging. So what's next? What do I need to do? Somehow fit the bracket, somehow attach this bracket. Now I want to do a mark here to mark where this bolt is resting and just cut it with an angle grinder. So what I did was I marked it, measured it, marked it, and used the angle grinder. I just cut out a square like this. I made 2 longitudinal cuts. I made 2 small cross cuts. Just chiseled it out, knocked it out in this direction and broke everything off. That's how it is, that's all. It fit well. Where? Everything is even, nothing sticks out. The gearbox is fully assembled, oil is filled, and everything is great. Next, we'll paint the gearbox. Here's how I prepped it, covered with tape. Here are the gear selector, the reverse light sensor, the drive sensor, the speedometer, where the drive shaft fits, the cup. I've prepared everything like this. I'll paint it while it's suspended so I can adjust its height. I clamped it with a bolt, attached it to the input shaft, the cable and so on. So I took this kind of primer. It's an acrylic primer. I diluted it, added hardener and thinner. It was a bit thick, so I mixed it and let it sit for a while. And the paint, I found some paint for myself. If I have any primer left, since I mixed a lot, I'll just store it here in my desk. That's it. I wiped this area with solvent, and if there's any primer left, I'll keep it. I'll paint everything here, cover it with primer. I need to take care of it sometime. Paint all the tables, paint everything the same color. Well, that's it. Now I'm starting to paint. That's it, my box is painted. It's light gray or dirty white, I don't really know. Basically the color doesn't matter. The main thing is it won't rust or corrode. That's it, this is the video I ended up with. Thank you all for watching. Good luck to everyone. Goodbye.